Lesson 5.7 is on systems of linear inequalities. This isn't going to be too much of a stretch past 5.6. It's just we're going to have multiple on the same graph. So it's two or more inequalities in the same variables. So if you have two or more inequalities that are talking about the same information, you've basically got a system. So a solution for a system of linear inequalities is an ordered pair that makes each inequality true. So if you remember from the 5.6 lesson, if I had a graph of an inequality, it might look something like this, where I have a shaded area, and the shaded area was the solution. Well, now that we have a system, I'm going to have a second inequality, and this one's also going to shade. Well, the area where they overlapped, which I'm going to outline here, this is called the solution space. So this is where the red and the blue overlapped. So any point in that weirdly shaped section is now a solution, because it's where it's a solution for every inequality in the system. So here I've got a system of linear inequalities. These would be graphed on the same graph, and an ordered pair. So we're going to plug in the x's and the y's to see if it fits both these. If it does, it's a solution. So let's start with this one. 5 less than 2 times 3. Plugged in my 5 and my 3. 2 times 3 is 6. That one's good. 5 is less than 6. All right, let's check the second one. 5 for y again. Greater than or equal to 3 plus 1. 3 plus 1 is 4. So that one works, because 5 is definitely greater than or equal to 4. All right, so yes, that one is a solution. All right, we got one more. So we'll erase our work for that one. Check the point -2, 0. That 0 is always nice, because plugging in a 0 is one of the easiest things we can do. 0 for y, less than 2 times -2. 2 times -2 is -4. 0 is not less than -4. All right, we don't even have to check the second one, because this isn't a solution if it doesn't work for both. This is going to be a no. All right, so this one would be in the overlapping shaded area. The -2, 0 point would not be, and that's what we're going to look at next. All right, we're actually going to graph the system now. Let's ask ourselves those two important questions we learned in 5.6. Is this going to be a solid or a dashed line? Less than or equal to means solid, because it's got the or equal to. And then shade above or below? Below, because y is less than. And this guy right here, dashed line, because it doesn't have that or equal to symbol. And then shade above, because y is greater than. All right, so let's actually plot some points. Y less than or equal to 3. That's that one I want us to recognize as a horizontal line. So there's y equals 3. And as long as y equals 3, it doesn't matter what x is. And that's what makes it a horizontal line. X can be anything, as long as it stays at the same height. And that's a solid line, and it should shade below. So for now, I'll just do a loose shading. We'll fill that in once we have the other line, so that we can see where they overlap. Second equation has a y-intercept of 2. So it's right here. And then a slope of 1. There'd be an imaginary 1 in front of that x. So up 1 over 1, up 1 over 1. This one's a dashed line, so we got to make sure we don't just connect it. We got to connect it with dashes. All right, this is a dashed line. And we shade above it. So I'm going to use red to shade this one. And do you see where they overlap? If I fill that in a little more, this area right here, this little triangle on the bottom left. Let me outline that for you quick. This is the overlap area. So our solution should be anything in here. If it's on this dashed line, it doesn't count. If it's on this solid line, it does. All right, so that's an example of graphing a system of inequalities. Now we can have no solution. So let's take a quick look at that. It's a very special case. First thing we're going to have to do for this system is get these into slope-intercept form. Shouldn't take too much work because y is already alone for both of them. So that one's already done. Just had to subtract 2x. Same thing over here. Just have to subtract 2x. All right. First thing to note, these have the same slope. These are going to be parallel. Part of getting no solution is that the lines have to be parallel. Otherwise, they're going to cross at some point. And you're always going to get a solution then. All right. Now, let's ask ourselves our two questions we always ask. This one is dashed and shades below. This one is also dashed, but shades above. All right. So now if we start graphing these, the first one, let's keep this in mind. Remember the questions we asked ourselves. Y-intercept of -1, so I'll start down 1. Slope of -2, that's down 2, right 1, down 2, right 1. And I can go backwards too, just to get some more points in there. All right, dashed line. And reshade below the graph. Now let's look at the other one. Y-intercept of 3. Nope, erased my writing. Y-intercept of 3 starts up 3, 1, 2, 3. Same slope of -2, so down 2, right 1, down 2, right 1, down 2, right 1. Do that all the way over. Still a dashed line. And this one shades above. So I've been describing that the solution is where the shading crosses over. Well, there's a tunnel in between, and one of the lines shades down, the other line shades up. These two never overlap their shading. This is an example of no solution. Very special case. The lines have to be parallel. The shading has to go away from each other. And that's the only time we can get a no solution. I can't think of a good example of when this would actually happen, though. All right. It's a special case, but I can't think of a good example of when this might happen in the real world where we'd get something that looks exactly like this. But it's a possibility, so it was worth touching on. Now we're going to do it the reverse way. We're going to write the system for the graph. It's probably the most challenging thing we're going to do in this lesson because you have to figure out exactly what you need. All right, we're going to ask ourselves these questions in reverse. All right, so let's start with this red line. It is solid, which means it should have the or equal to symbol. And then which way is it shaded? Well, the part that's the crossover is above the line, so we have to assume that we're shading above the line. All right, and then we look at the blue dashed one, ask ourselves the same thing. This one is dashed, so it should not be or equal to. And where the shading happens is below this line. All right. Now the red line should be easy because it's a horizontal line like we've been seeing. So the line itself is y equals -2 because it's a horizontal line at -2. It has a slope of 0 because it's not going up or down at all. But we don't use an equal sign for an inequality. We're shading above and it's solid. Above means greater than. Solid means we include the or equal to symbol. So that's how we read the red line. The blue line, we have to get our slope and our y-intercept. Luckily, it goes right through one of the points on the y-axis, so our y-intercept is 0. So for this one, we have a b value of 0. And slope, well, let's count. It's up 1 over 1, up 1 over 1. All right, so this is going to be 1 over 1, or just 1. Fill in y equals mx plus b. Y equals 1x plus 0, or just 1x, since the plus 0 doesn't do anything. But now let's change our equation into an inequality. It's dashed, and we shade below. Below means less than. Dashed means we don't use the or equal to sign. This is the solution to the problem. Honestly, there really shouldn't be a whole lot of algebra in a problem like this. It's just about being able to read what's in front of you. All right, we know we need slopes and y-intercepts. It's just easy for me to identify that this has a slope of 0 because it's a flat horizontal line. Then we also need to ask ourselves these two questions to figure out what symbol to use. This is kind of tying a lot of stuff together for us. We'll do one more. Last problem for the video. All right, let's do the same stuff we did before. Ask ourselves some questions. This is a solid line, but now it's a vertical line. We don't ask above or below. That wouldn't make sense. For a vertical line, we ask left or right. This one's clearly shaded to the left. This one is going to use x only. There is not going to be a y in this equation. All right, this makes you draw back on graphing lines like this from, gosh, I don't know, like chapter 3 or something, a good month and a half or 2 ago. All right, the blue line, it's dashed, and the shading happens above the line. Now that red line right there, when we see a vertical line, we know it's x equals something. So x is always the same. It's always at positive 3. Y doesn't matter, so y isn't part of the equation. And we don't use an equal sign because it's an inequality. Well, is left the smaller numbers or the bigger numbers? That should be the smaller side. So this is x less than 3. Everything's smaller than 3. And because it's solid, we include the or equal to. Now for the blue line, this is a normal equation. We need a slope and a y-intercept. We've got a point right on the y-axis at -1, so that makes this easier. Then if we count, this graph goes up 2, right 3. Up 2, right 3, 2 over 3, rise over run. Let me write that not in the glare. M equals 2 over 3. So up here we would have y equals mx plus b, 2/3 x minus 1. But we don't use the equal sign. We use this information. Above means greater than, and dashed means don't add the or equal to sign. This is our system for this graph. Again, if you need a refresher on how I got this x less than or equal to 3, it might be worth going back and looking through your notes and looking through previous videos. Because we have done this before, back when we were learning about finding x and y intercepts and using standard form to graph stuff. This should be a little bit more comfortable for us, but the top one might trip you up a little bit if you don't go refresh yourself.